we are back. Now is the moment to start our second block of speakers. Now it would be Ricardo and Samuel who are going to share with us their talk about scaling. Yeah, are you ready? Good. Let's welcome them with applause, a round of applause.
Thank you. So, is it working? Yes. Hello, everyone. I was warned that it was low, and it was not that low. Hello, everyone. Thank you for coming. Today, we're going to be talking about event-based autoscaling and how we apply it in Glovo. Before we start, can I get the hands up? Who is working with Kubernetes here in this room? Cool. Okay. Who has dealt with autoscaling? Okay. Fewer. And who has touched at all event-based autoscaling? Okay. So for those who all the answers were no, we still have some canapes at the end of the room if you want to go around there. But for the rest, I hope that you can learn something from this talk. So we'll introduce ourselves first.
Yeah. Hello, everyone. Ricardo here, staff engineer from Infra Runtime team.
And I'm Samuel, senior cloud engineer for the infrastructure team. So let's go a bit with the basics of autoscaling first. When we are talking about autoscaling, the first things that come to mind is actually resource-based autoscaling. So the standard approach for Kubernetes and the thing that you would think about is, I have a request to hire CPUs, so I need to scale out my workload. Or I don't have enough memory for my workload, so I'm going to scale up. All those basics are based on metrics that you get from the pods. And these are the baseline, let's say. Normally, you will be using horizontal pod autoscaler. Vertical pod autoscaler exists, but we're not going to get into that into this talk. And you would define the basics, like there is an amount of replicas in there, there is minimum, maximum, and whatever I'm targeting to scale up or down. And that works quite well whenever we have workloads that require, let's say, to get from these metrics. But also we can use several strategies whenever we are scaling. These are strategies that are used in the industry, and you define them basically. You can have some sort of a passive approach where you would need for the load to continue rising over a certain amount of time, something more balanced, or whenever you need very aggressive up or down scaling. And keep in mind that you define this. So you don't need to follow the same approach for upscaling and for downscaling. You may want to have very fast upscaling, but then maintaining your pods up for a while. So you have more sort of a passive approach to downscaling. You basically define a percentage of it, and it's important to know about the stabilization window. Basically, this is to avoid flapping whenever you have a peak. So over the stabilization window, you will keep the maximum value that you get for that scaling. What are the limitations that we get with HPA? Basically, it doesn't work for everything. So if you think about an Nginx, sometimes it's not about the CPU that the Nginx application is consuming. Sometimes what you want to know is how many requests you're getting in and out. There's also the cost. HPA doesn't allow you to scale down to zero, so you're basically spending money all the time. Even if in a deployment, you could potentially have 0 replicas whenever you don't have any kind of load and save some money. And there's no pauses. Maintainability with HPA, it's a bit tricky because if you are doing some maintenance, some upgrades, and you don't want to touch the scaling up or down while you're working on that, you're going to run into issues. So what you have to do is either you have to deactivate the HPA or potentially target to a different thing. It would be much better if you could just add an annotation and pause that for a while. So with that, what necessities do we have that we don't get from horizontal pod autoscaling? Scale based on better metrics for our applications. We want to reduce the cost, very important nowadays, and have a better maintenance.
Thank you, Sam. Okay, now the Sam introduced a little bit how it's the autoscaling working for the common metrics like CPU and memory. Now, before we go to the autoscaling topic that we want to a little bit introduce all of us to about event-driven services or event-driven patterns or architectures. Basically, when you are talking about event-driven architectures, that you have like a producer, an event broker, and a consumer. that the producer of the event can be anything. Let's say, I don't know, Alexa turning off a light, or adding a new order or a new checkout in the shopping cart. Any kind of event, it's basically traduce it and something in a flag in your system. And this is a state change. So there is a event producer that create this event. There is an event broker that is storing this event in different type of common topics, let's say. It depends of the broker itself. And there is other consumers that are interested to have these events and do something in your system. So when we are talking about autoscaling itself, we are introducing here Keda. Keda is basically means or stand about Kubernetes event driving autoscaling. Is a product that is open sourced and introduced to Kubernetes an easy way to interact with different kind of metrics out of the box and provide a single interface. This vendor agnostic and enable all this event-based architecture to scale based on different type of metrics, and didn't require any change in your application because this is outside of your application. It's basically defining how is the behavior of the HPA that Sam introduced, but exposing other type of metric for it. If we go a little bit about the Keda project itself, this was a collaboration between Red Hat and Microsoft, introduced it and donated to the 2020 to the CNCF, and also moved to incubation phase in 2021. When they released the version 2.0 was production ready. So currently there is the version 2.8. And there is a cadence of the releases around 3 months or more or less. There is a lot of features incoming and there is a lot of contributors in the community. There is a big project that there is a lot of traction because it's introducing to Kubernetes a lot of type of sources that are not out of the box for it. So if we define a little bit in details about how Keda works, if you have like your cluster and you want to start using Keda, usually you go with the Helm chart. And this is pretty straightforward. You install the Keda into your cluster and you have a namespace. And you can see there are just 2 pods. There is a metric server. There is the one that is exposing the metrics to the HPA. So remember that the horizontal pod to scale is working in Kubernetes, but you are not in charge of that because Keda is creating the HPA for you. And also there is the controller that basically Kubernetes is a pattern. You have an operator or a controller. It's a custom resource definition. So it's implement the interface or the API for Kubernetes that you can use these kind of objects. And about the CRDs and the custom resource definitions, the main one for Keda are the scaled objects. That is the one that we are going to define a little bit later, that basically manage all the deployment, stateful set, so that kind of workload that have an state. And the scaled shop, that this is more for the use case that you have something like long running shops so that you can process something. And when you have the process done, you can just exit the workload and you don't need something running there. That is a scaled shop means. And then they implement the trigger authentication. This is important also because provide a single interface to create the authentication layer and abstract the user to need to implement this trigger authentication for every kind of service. You have different sorts of services. You have a single interface that you can use to connect the services with authentication. You can see here how it's work more or less, but we are going to define with some use cases just to not go too much in deep. If we go a little bit about the basic manifest of the scaled object, is maybe quite big, but the things that are the most important here is you need to define what is the type of workload that you are going to scale up. And this is a scale target reference. Usually in Kubernetes, you define the API version, the kind of the type of the object, and the name. Let's say that you have deployment and you want to scale up, you have just to define the selector. Then they have a lot of fine-tuning configuration, like the polling interval, or the scaling down period, that is more or less related to all the behavior that Sam mentioned about how the scaling is working for the scaling up faster or the scaling down a little bit slower. But the more important thing here is the replica count. You have the minimal, the maximum replica count, the same as HPA. Basically, how many pods you want to scale up or scale down. And the idle replica count. This is important in Keda because also Keda provides the functionality that you can scale down directly to 0. If there is not workloads to be consumed or any shop to be consumed, you can scale down all infrastructure and you don't need to have nothing running there. And then at the bottom, you can see there is the triggers. This is important because it's where you are configuring the sources of the metrics. Talking about Keda itself, they have more than 50 scalers supported. There is a lot of them. We are going to talk a little bit for Datadog, Kafka, and SQS because we have some use cases for that, but there is a lot of them. It's not just for the AWS, there is Kinesis, CPU, memory, there is Prometheus as well, and there is a lot of databases and a lot of sources of scaling that you can use to scale up your workloads. Now, the idea here is try to showcase a few use cases just to try to understand how Keda works with different type of triggers or scalers. Let's say that we have an engineering team develop a worker that need to process something asynchronous, and they want to consume all the events as fast as possible and keep the topic in Kafka around 5. So what we need to do there? We need to define a trigger, right? So the scaled object is the same because we know what is the name of the workload, and we need to define some configuration for all triggers. In this case, for Kafka, they have some specific fields like the consumer group and the topic. So you can do the target for the consumer group and the topic, and the Bootstrap server also if you want. There is also the trigger authentication that is not here, but basically it's configuring all the users and password for the Kafka broker. And then you define the threshold. In this case, we are defining the threshold of 5, and there is like activation lag threshold of 3. In this case, the activation lag threshold means that if you don't have nothing to process, and you want to keep or your workloads at 0, if there is 3 of the lags in the metric that you are monitoring, then Keda is starting to the first spot. And then before that, it's just HPA scaling up and scaling down. So let's see a little bit how it's architected here. You have a producer that is pushing something to a specific topic. You have for topic different partitions, and you have a consumer groups that are connected to a topic and partition. So the scaled option for Keda is monitoring the Kafka broker and getting the lag for that topic and that consumer group, and then defining this metric and exposing to HPA, and HPA is scaling up and scaling down based on that metric. Something to highlight this is Keda also understand the number of partitions that they have for different topics. So it's not scaling up more than the current partition that you have. So that is if you set the allow idle consumers in false, so you don't have workloads that are not connected to the partition because there is no partition available. This is important because you don't want to waste money in workloads that cannot be connected to a specific partition, right? Another use case is a web platform that says we have a front-end team that they want to scale up based on requests per second because they want to reduce the latency, and the CPU maybe it's not enough or it's not enough faster for them. In this case, we have like a Datadog trigger, for example. We are showing up Datadog because we are using Datadog, but there is Prometheus and New Relic and other also sources for that. In this case, for example, for Datadog, you have the trigger authentication to define the AP key and all the connection, but about the trigger itself, you have the query, so you can define, like in this case, the request per second and roll up 1 minute, and then define the query value that you have, you want to have to scale up or scale down. So this is an easy way to define the same deployment. You don't need to change nothing in your service, and the key is in getting that trigger, that query value from Datadog. You can define the polling, 1 minute of polling, 30 seconds, 10 minutes, anything that you want. And then the HPA is scaling up and scaling down your service. In this case, we are defining that query, but it can be anything. It can be latency, or it can be different kind of metrics aggregated together. And then, and this is that I already mentioned a little bit, but this is scale to 0. And let's say that we have something that is not real time, that we something that need to be processed in a SQS queue. But we have a limited budget because we don't want to spend too much in this. But also we know that there is a spike of requests starting the working day. So in this case, for example, Keda provide the functionality to aggregate different type of scaling. We can have here the SQS and cron, for example. We have the trigger, the SQS queue. We can define the queue name and the queue length that we want to keep to scale up and scale down. But also in this case, for example, this is another one. This is type of cron. You can define the starting day, and we have desired replicas of 10 at 7.5 and the end of the 8 a.m. So in this case, the mandatory thing is we can have 10 replicas at the beginning of the starting day, but then it's just we're scaling up based on the SQS queue, length, and so on. Also, as I mentioned before, the idle replica count. If there is nothing to be processed, so the workloads are going to scale out to 0. In this case, what the same is the architecture in that we have something that is producing an event that's pushing that in SQS. And the consumers are working as usual, but there is the Keda that is triggering and polling the AWS API, getting the value of the current value of the queue, and exposing that to HPA to scale up and scale down our workload based on that. So talking about Glovo itself, how we are integrating this in our platform. Usually we expose to the users a little bit, and not to the higher level, so try to not expose all the scaled objects to the user because there is a lot of configuration there. So we provide that out of the box with a Helm chart, and we ask a few details about that, like the escalation type, in this case for the SQS, the name of the queue, and the required queue length to scale up and scale down. So in this way, we are abstracting the user a little bit for all the required fields. And also for that, we are using pod identity, using IRSA, that is a service account for IAM roles in Kubernetes. So the user also didn't need to take care about how their authentication working with SQS. Is everything abstracted out from the user itself. So, well, Keda looks amazing, right? There is a lot of things that can be done with that. So let's recap a little bit. After that, I think some of you probably ask, okay, this Kubernetes, I understand nothing about that. I hope not too much. But if we go back to the Keda itself, let's summarize. We can scale out to 0. This is important because we don't want to spend money when there is nothing to be processed. It's important for the developers that can be metrics aggregation that enables a lot of advanced scaling behavior. So you can define different type of metrics and scale out based on the real workflow and the real traffic. And also the scaling are platform specific. There is a lot of things that are related, for example, for Kafka or for Datadog queries, so that kind of thing that can be defined by platform. And that is really tied to that. So let's go for the demo now.
Thank you. So for sorry. So for this demo, the repository is still closed source, but we will open source it as this presentation finishes. Basically, let me put you in situation. We're going to create a kind cluster to have a local environment to deploy all of the different Helm charts that we will use. We will be using an SQS queue and IAM role created previously to check the escalation and just the AWS CLI to send some example messages. So let's go with it. I'm actually going to need both hands to zoom in a bit. So I'm going to use the most expensive microphone pole in the world. Thank you. So let's start with it. Sorry, I hate Zoom. There we go. So we are basically creating the node first. I hope that you can see it well. The cluster first. So this is going to take around 30 seconds. After that, it's going to deploy the Helm charts for our Keda and all of that. Like this. Yeah. I can zoom in. Oops. There we go. I hope that's enough. So yeah. So basically, it's what it's doing. Yeah. Oh, it's not zooming in there. Okay. I'm sorry. This is what you get. Cool. So once the initial setup is done, you have a makefile for that. You can follow the repo after the presentation. We're going to deploy the different resources, which are basically going to be our simple Nginx deployment that has nothing specifically for Keda, and the scale object through authentication to login into AWS. As you can see here or not, the scale object is already there, and you can see there is a minimum of 0 replicas. So what this means basically is that we're going to start the deployment from a basic of no replicas at all. And until we push those messages, it's not going to scale up again. So as a little bit positive, thank you. Explaining a bit, the only thing that the scale object has here that's relevant is that it's targeting the deployment that we are using. And we have the things that were described by Ricardo before, which is basically the queue. We want to scale every 2 messages in the queue. We're going to send 10 messages from our base load. So that basically means that we're going to scale up to 5 replicas if you can do basic maths. So yeah, let's continue with it. As I mentioned, there's nothing specific about the deployment that is setting this. This is all from from Keda itself that we're going to do. We're going to see the scale object here. We're going to see the deployment and how it scales up, and the HPA that was created by Keda itself. The first thing that we're going to do once we send some load is we're going to see the scale object turn into active, which basically means that it has received those messages, it has detected them, and it's going to kick off the escalation for the deployment. The SQSQ has a very short remaining time for the messages, so you're going to see it scale up and then scale down really fast. This is just for purposes of not being here for half an hour. But basically, also you can see that actually the target is currently unknown for the HPA. This is because HPA is not prepared to have 0 replicas. The way that Keda controls that is with the metric server. Once it receives the first messages, we will see it go up again. Yeah, let's go. So we have sent our messages, and now, anytime now, we're gonna see the SQS turning into true. And once that happens, we will proceed with the escalation. So that's the, yeah, if you want to go right, yeah. So the moment that it goes up to true, the HPA is gonna become active. You can see 0 out of 2, so it already detects that there's something moving on. Goes up to the 10 messages that we've received. It's already scaling up. 4 replicas, it's gonna go up to 5. As I mentioned, the retention is really short. So now we have already seen the scale up. As you can see, it's pretty straightforward. And once the messages go down again, we have a threshold period where the replicas are gonna still be maintained. This is completely customizable. And once that threshold period passes, it's gonna set there we go, scale object to false again. It's gonna wait until that period passes, and we're gonna get the replicas back at 0. Once we see that, yes, that's it. So basically, that way we can go up from the SQSQs, goes down again. Let's not go into the takeaways that we should take from this talk. There is not a magic solution for everything. No one fits all. Depending on your applications, you have to choose what's the best scaling strategy for you. Always remember that Keda also allows you to scale by CPU and by memory. So from Keda itself, you can also use the standard strategies and then make use of the extra features that it has, such as the cost optimization. So cost matters. Infrastructure is very expensive, and it's one of the main reasons of the tech debt that we have in organizations. So we always have to keep that in mind, make use, stage environment, maybe scale to 0, these kind of things. And this is in a constant evolution. As Keda is highly supported, Keda has a lot of scalers, there's gonna be improvements coming up, there's gonna be new scalers coming up, and we always have to keep up to date to see which one fits better for us. Thank you. Now, yeah, if you have any questions? So the question is that if we set the scale, let's say the minimum replicas up to 0, as an example with Kafka, what should we expect regarding cold start and how much time there? Is it configurable? Do you want to answer? Or?
Yeah, I just say that there is a parameter that's called active threshold, but basically it's monitoring how much lag do you want to have before startup. So I don't know, you can define that, say, okay, I want to start up when there is a lag of 10, for example. And then you have the polling interval. You can define how much are you polling the Kafka broker to have these metrics. I don't know, let's say you have a minute for polling. So you can wait 1 minute to get the metric back and then do the calculation and start up or active your workloads or not. And then you have like a startup of your service itself. If you have, I don't know, 1 minute to have your service up, this is a summarize of all these metrics, basically.
Just to add a bit on that, remember as Ricardo presented that you can have combinations. So perhaps if you already expect at certain time that you're going to have a workload, you can perhaps combine that and make sure that at those critical times, you already have some minimal replicas going on. and it's at those other times where maybe you don't expect a certain load that you can check all of the things that Ricardo mentioned. So maybe depending on how critical this is for you, you can pull more or less. It depends. You can combine both things. Okay. Online question from Rafa. Is Keda available for the current MLP clusters, starting from which Kubernetes version? Okay, this is a very internal question. If anyone is seeing us from outside of Glovo, I mean, the answer, let's say, for all public is that we are so Keda is already supported in our internal, let's say, bootstrapping within Glovo. And we are going to start rolling out with some testing services that already needed. And from that, we expect to do more of a general rollout, probably Q1 of next year.
Yeah, it didn't matter really that because you are scaling pods, and then the pods, if you have the right affinity to go to spot or on demand, you can just select where is the underlying infrastructure that where is running. Yep. Wait. Okay, but lag is in milliseconds. That message is taken to be read from the Kafka topics. Can you elaborate a bit more? What is it? Well, this is really tied to the Kafka itself about what are the metrics and the polling and what is the lag for that. I think that we can reply it offline. I think it makes sense right now about the.
Okay, so the question is, how does the scaling based on requests per second work? And if we define how many requests per second can a single pod handle? So as we mentioned before, you base the metrics on the scaler. So different scalers will have different metrics to retrieve, let's say. In this case, the request, I guess that it also depends. If you're getting the request from Prometheus, right? If you're getting the request from Datadog metrics, or it depends on what you're using for that. If we are talking HTTP requests, I understand here.
Yeah, that it depends a little bit more in your service itself. You need to understand how many requests per second you think that one instance of your service can handle, and then you can scale up or down based on that metrics. I don't know, if you have a service that have multiple threads or multiple workers that can handle more metrics in one single instance, you can fine tune this request per second to scale out a little bit less. But it depends of the service itself and how you are getting the request per second. In this case, in the example that we are showing up, that we are doing a roll up. So we are getting the max value from the last minute of the request per second, and we are scaling up based on that because usually engines didn't use the CPU in the same way that the request per second can handle, because if not, it's not handling more requests, but the CPU is not increasing in the same way. So this is a better metric than the scale out later than the CPU itself. There is any other question? Yeah. Yeah, Keda is exposing events directly and also exposing metrics with open metrics. So you have all the events that whether it's a scaling up happening or scaling down. So you have all the events that are currently redirected to Datadog. Yeah. Anything else? Yeah. Yeah, usually in Kubernetes, you have two types of scaling. You have the cluster auto-scaling and the pod auto-scaling, in this case, the HPA. If there is no pod to be allocated, the cluster auto-scaling is downscaling also the instances. So the underlying infrastructure is also removed. So you don't have the cost of the instance. That is the root of the cost. Okay.
Thank you.
Okay, team. So the next talk would be at 12:30. So we have 15 minutes of break. By the way, in lunchtime, we are going to have some pizza. So you might want to stay around.